So let us have a brief glimpse of the solid state physics. So in this lecture we shall touch upon the notion of crystal lattices, bonding forces, the different types of materials, the energy band structure of solids, and we will have a brief introduction to semiconductors. So in a crystal lattice, the atoms are packed in a regular fashion over the entire volume of the volume of the crystal, and however the packing differs from material to material, and we have a nomenclature based on how the repetitive structure looks like. So accordingly, we have the primitive cell where you have a cubical structure with the atoms sitting at the vertices of the cube. Then if in a primitive cubical structure we have one more atom located at the center of the cube where the diagonals intersect, we have what is called a body-centered cubic unit cell. Similarly, if we have an atom located at the center of the faces of the different faces of the unit cell, then it is called a face-centered cubic unit cell. And then if we have the atoms located only on the two faces opposite to each other, it is called an end-centered cubic unit cell. So the atoms or the ions are packed together tightly with the help of electrovalent bond, and when an electrostatic force of attraction acts between the ions to hold the ions very tightly together. For example, in case of an NaCl lattice, each Na plus ion is surrounded by 6 other negatively charged Cl minus ions, and vice versa. Now the materials are classified into 3 kinds on the basis of their conductivity. Conductors are those materials in which free electrons are available either at room temperature or even at absolute zero. Metals are examples of good conductors. On the other hand, there are materials which have got low conductivity at normal temperature, and at absolute zero there is zero conductivity. On the other hand, at high temperatures they have reasonably high conductivity. They are called semiconductors. The third type of material in which the conductivity is very low at any temperature whatsoever, and it requires a high voltage to be applied across that material to initiate any conductivity. Those materials are called insulators. So here is basically the energy band diagram of the 3 different types of materials: metal, semiconductor, and insulator. In case of metal, as you can see that there is an overlap of the valence band and conduction band, which leads to the fact that there are free electrons available at all temperatures. In case of semiconductors, there is a gap between the valence band and the conduction band, which means that the charge carriers located at the valence band require some energy to get promoted to the conduction band, at which they are free to move. And then in case of insulators, the gap between the valence band and the conduction band is wide enough, so even at elevated temperatures it is not possible to promote an electron from the valence band to the conduction band and make it conducting. So this leads to the variation in conductivity of the 3 different types of materials. Of semiconductors which are of particular interest, we typically use either the group 4 elements, or we use a combination of group 3 and group 5 atoms as some compound semiconductors. If we use group 4 elements, we typically use group 3 and group 5 elements as dopant impurities. If we use group 3 dopant impurities, they act as acceptors. If we use group 5 impurities, they act as donors. So as you can see that here a silicon crystal is doped with antimony, leading to the formation of donor N-type semiconductors with an extra electron not tied to any of the atoms, and it is freely available. On the other hand, in the second case, as you can see that a silicon crystal is doped with boron, where one extra electron is needed to fill up the silicon boron bond and leading to the formation of a hole.